So pet data service. Before we open it, so let me show how I created it. So you will create assignments the same way. IntelliJ, a new project, Spring initializer, assignment 2. Okay. Create Git repository, Java grade Groovy, Sheridan.yourlogin name, assignment 2, 1717, jar. Then clicking next. Now you need to select, and what you select now it's different because it's different project. In web, you need to select REST repositories. Not this one, HAL Explorer. This is browser for data. But just REST repositories. Okay. I will provide PDF file with the steps. Okay. REST repositories, here in web, REST repositories. And in SQL, you select H2, it is database, and GPA for object-oriented access. So it is only three features. REST repositories in web, Spring Data in SQL, Spring Data GPA in SQL, and H2 database. I don't include templates and other things because they're not used. And after this, if you click create, everything is included. Right? Questions at this moment? Now I will open open example for PetDataService, and I will explain what is that now. Right. So PetDataService, copy, IntelliJ, get from version control into SpringBoot folder, Control V, and clone. Trust project. It's coming. Next, I want to open student data example to compare. There is nothing new in student data, but I want to have it side-by-side comparison to show what is different. Okay. Open project. Oops, cancel. I deleted this stuff. I just deleted it, so I don't have it. I have to clone it. Okay, whatever. Get project from version control. You don't have to. I forgot that I have to keep it. Okay. Okay. Student data. Control V. Clone. New window. We discussed this a lot. Security is not explained. I will explain it in the next week is the security stuff for it. In student data, it's still initializing. We had two SQL files. One was creating tables. The other one was populating tables with data. So it is in main resources. Schema SQL is creating tables. Data SQL is adding data to it. When we open PetDataService main resources, we don't have that SQL. See? Why this program is showing data? Where it's coming from? Data is also in memory, but it's not. It is added by JavaScript. Let's open application properties here and application properties in this project. In student data, we have DDL out and none. This means do not generate SQL tables based data inside of entities, based your entity classes, based on entity classes. Why? Because you have a file schema SQL that creates tables. In PetDataService, you have instruction generate DDL true that explicitly says create tables based on entities. So this is why you don't have explicit creating of tables using SQL, because it is creating tables based on your description of entities in your Java code. Okay. Next. In student data, we had also data SQLs that adding data to the program. Where this adds data? In Java, I have a Java data GPA. I created a class called data initializer. Let's double click it. It is marked with add service. It means the system is forced to create object of this. Okay. And when it is creating the object, obviously it will scan, it will find post construct. And it will call init after calling constructor. Firstly, it will call constructor, inject pet owner repository, and after this, you see, I'm saving data by calling repository. And data is just created by calling constructors and save. So this is why it doesn't have SQL files, because tables are generated automatically based on entity description. You see, I have pet entity, pet owner entity, right? So there will be tables will be generated based on those classes. And data will come from data initializer, post construct, init, and this data. Add pet, save, and so on. So this is obvious difference. Also, in student data, we have folder for templates. In this case, we just don't have folder for templates because there's no templates. We didn't even include them. But in this example, I have in static folder, I have index.html. This is not a template at all. It is just HTML file, a regular one. And because it lives in static folder, this will be used by default. So when you go to localhost 8080, it will show it. It is not essential part of the program at all. This just contains links that you can click and see the data. Like any address in the link, you can type it in address line and copy paste it in address line and see the data. So this file is not essential for any functionality. It is just extra information where this data lives. Right? Also, if we go to application properties, we also see this. This will be folder of the JSON data. So this way you can rename it, put it in different location. If you don't specify it, it will be root of the folder, just slash. And if I put just slash, it will go into conflict with index because index is shown on slash. So I had to customize it. What else is interesting? Yeah, nothing else. So let's run it and see how it behaves. By the way, before we run, let's first look at data structure of it. I have pets and pet owners linked to one-to-many. From owner side, it is one, many on pet side. So let's open pet. On pet side, we have ID, name of the pet, pet kind. You see a specified column name. Not necessary at all. Why it's not necessary at all? We typically need to specify names, really need to, when tables already exist or created from SQL. This way we need to make sure it is matching. When tables are generated from class, it will use some defaults. And it will be guaranteed to match because it is generated from the same code. So when you access it, you will have, you use these classes to access it. So although I specified pet kind here as the name of the column, it will generate some. I just don't remember what, but it will generate something. Most likely even this. If we delete this specification, we can open H2 and see. Okay. Well, we will experiment. The same applies to join column in many to one mapping. It will create some ideas, some foreign key in pets table based on variable name in owner. No, based on this variable. Okay. Most likely it will be on owner ID by default. So naming specifications, this name, is necessary if you want to make sure that it is the name what you like, so you override defaults. And if table exists, you are kind of pushing your luck, because if by default it's not what you have in your table, it won't work. This way you'll have to override it. Okay? So what do we have here? Join column, and this is foreign key, right? This is foreign key name. And nullable false, it means every pet should have pet owner here. So we have a pet, we create pet owner before pet because it's linked. Constructor, what else? Setters and getters. And something interesting here. Pet owner, get owner, set owner. No, nothing. Oh, here it is. Okay. This is additional customization. And when you say write JSON getter, it will create data field in the JSON, owner ID, based on the name of the method. Why? Because this is not part of the JSON, it's just table name, column in the table. And by default, IDs are not shown in JSON. So you have to somehow show if you want. Typically, you don't need to. But I'm showing how to customize, how to add additional properties using methods. This way, you can insert data into JSON directly by declaring methods like getters and bucket JSON getter. This will insert data into JSON, for example, calculated data. And this is indeed calculated because owner.getID is calculation, right? It's a result of a method call. Right, so let's open owner, pet owner, and see what is there. Unlike pet entity, I provided table just to show that you can provide table or do not provide table name. If you don't provide table name with table, it will make up something by default. Class name in capital. And in this case, I decided, okay, I will provide table name. It will make it capital anyway, but with underscore. If you delete this one, it will work because table is created based on the description of the class. It will use the same default, so it will work. The same, you can delete this thing and see what will show up by default in H2 database. This is more interesting. This is a relation backwards. When we create relations, we don't have to create it both ways. We create it both ways only when we need to. For example, we want to display it in our JSON, right? Or a link in our JSON. When we link objects, we create these links on as-needed basis, or as needed. In this case, I decided to create it both ways. Map it by, it's a variable name on the opposite side. So owner, it's a variable inside of a pet, referring to this object, map it by. Cascade type persist. This is interesting. Cascade type define how to deal with these objects when you apply this operation to this one. Persist means save new object. Okay? By default, it will not do anything. So when you save pet owner, it will contain, it will cascade save new object, persist, to all pets of this new pet owner. So what is the logic? You create pet owner object, add pets to the list, call save on pet owner, and it will save pets. Persist, it is save new object. This is what the program is using. So let's do demonstration here. New pet owner Patricia Johnson. I created add pet method to Patricia and pet repository save Patricia. It will also save pets because I cascaded persist. So let's look at pet owner add pet. Pet owner add pet. Because I add pet to the list, but since pet has a link to owner, I create this link, assign this link as well. Just because I'm using cascade persist, when I save pet owner, it save new, it is persist. It is cascading save new to pets. There is another save called merge. A merge, it is for new and update data. So if I say merge, it will cascade not just for new data, it will also update tail. And there is also cascade delete. When you delete owner, it will also delete data, delete all pets related to the owner. What if you have more than one cascade? For example, you want to use it for delete as well. Not just for save, cascade also for delete as well. So let's open that cascade. Pet owner. If you have more than one cascade, you can just create arrays this way and put it comma separated, cascade type. Cascade type, for example, remove. So this way, when you remove, sorry, it's not delete, it's remove. This way, when you remove owner, it will also remove all pets associated with the owner. Okay. There is also cascade all. Cascade all will apply to everything. All operations will be cascade all. Okay? This will cascade save, cascade delete, cascade merge, cascade persist. So this example is using cascade, but in particular it's using only cascade persist, not other cascades. Cascades make your program logic simpler, like in this case initialization. When I save owner, it will also save pets linked to the owner. There is a little bit trick when you call delete pet. So let's find this logic. Oh, there is no delete pet in this program. So, okay. It shows in separate program delete linked object. When you delete linked object and save, this way it will not do it right if you remove object from the list based on the name. It is not a property of this, it's not a property of database. It is the property of how you remove objects from the list. I will discuss this separately. Okay. For assignment, you are asked to create tables populated with the data and show. Right? So delete will never come up. But I will discuss delete in separate example. It is follow-up example today. Questions? Yes?
Do we need to then, like, okay, this application displays it as like a, you go to this link and it gives you the JSON, so we should display it in a table.
No, okay. There is no table here. I didn't run it yet, so let's run it and see what it does. So let's run. Okay. When I go to localhost 8080, it shows index file, index.html, with links to data. If you don't create index.html, you don't have this page only. And this page is not an essential part of the program. It just shows where data lives to you, to browse. For example, if I go to API pets, it shows generated JSON from pet table. We don't have any control over how it looks. Yeah, it is whatever comes by default. What we can control is how pets call it. We can rename this piece to any place. We can rename this piece. We can rename this piece. This is the only thing that we can do.
So
yes.
Kind of thing for the assignment then?
Yeah. This can be customized, but the rest is just fixed. You cannot do much. In assignment, you do it simple as possible, always this way. Okay. We will learn how to create it from scratch, and it's not totally from scratch, but this way it is customizable. And obviously that involves more coding. So going back, this was list of pets, and they live in /API pets. Okay. This is generated from class name and made plural. Class was pets. They made it small and made it plural. It is not from table name. If table name potentially can be different, if you customize it, it will be different. So going back to index. So this is pets is coming from class name. If you go to pet/ID, it will be JSON for just one pet, and this is ID of that pet. Please notice that this is showing ID, but by default it doesn't. This came from extra customization that I added. In Java config, I created, this is student. In Java config, I created REST config that says expose ID for owners and for pets. If I don't have it it will work, but it will not show this, and it's fine. By default, why it doesn't show this by default? Because ID is duplicated here, you see? So they decided not to duplicate data because ID is there. So by default, don't get scared if it doesn't show this one. It is not a bug, it's a feature. Because ID is shown in the address line here. And this is location itself, and this would be location of all data of owner of this pet. So this would be owner of the given pet. So if we copy paste this here, we will see the owner of the pet. I created link to it. You see API pets2, it is what we just saw, and this is owner of pet2. So this will be data, Patricia Johnson, she is owning that pet. Can we see all pets of her? Here it is, all pets of her. So this repository is providing not just data, it's providing links how to find other data. Right? So it makes it kind of extra information. So what do we see here? It's a data about data, right? So it's called metadata, data about data. So this is, it makes it browsable, and I'm using. And this would be owner of pet with ID 2. If we want to see all pets of owner with ID 4, it will be ID 4 pets. And if we want to see specific pet of this owner with this ID 5 of that pet. So this would be dog relay. Okay. And we can go back to that owner this way, see other pets and so on. So it made it browsable. I already said that pets is coming from pet name of the class, which is plural, right? Next, owners. The name of the class is pet owner. Why it's owners? It is owners because I customized the name. I overrode default behavior. Where it is overwritten? It is overwritten in pet owner repository. You see, path owners. Right? It may appear owner. It appears as owner link in pet owner. So this is overwriting that. Otherwise, it will be pet owner. And this is overwriting owners here. No, this is owners, where it is? Collection resource relation. It will be owners of pet. Relation to pet, owners of pet. So there are three links to overwrite. Path, it is this. Owners of a pet, and no, sorry. Why it is plural here? Collection resource. I don't think it's used here. But I'm just showing that it's possible to override, for example, for many-to-many relationship. And this is definitely used owner of a pet. Otherwise, it will show pet owner. And what it will do it in a camel case, starting with small letter. Instead of owners, it would be pet owners, but starting with small letter camel case. I tried, I didn't like it, so I overrode it, and I'm showing how to overwrite it. In your assignment, definitely, it's not required. It is just demo that you can change if you don't like it. Questions? And IDs are not shown by default. In order to show IDs in every object, I created customization. And I also create, in order to see pet owner ID, I created extra piece in pet. I lost where it is. Somewhere here we saw it. Oh, here it is. Get owner ID, and it shows owner ID as this. So let's find pets. You see? Camel case, but this is small. It's like a property. It is generated based on name of the method. Before we go to next example, let's discuss how to see data. This is we already saw that data is browsable through HTML, through browser. Right? We can also see data inside of H2 console standard way. If we type h2-console, enter, it doesn't show because it's not running, so I need to run. Why we can see console? Because I said enable console, because of this. It doesn't come by default. So now when we go to H2 console, H2 console, if you click connect but it doesn't connect, it means this is not the same as this part. So in this way you need to copy this piece here and it will connect. Connect. So when this program is running, you can see data, you can see what tables are created automatically, you can see data inside of tables. For example, pet owner, run, you got pet owners. And you can also see that this is foreign key, right? Which is ID in pet owner table.